Thanks everyone for coming to listen to my talk today. Very, very glad to be back here at DDD Adelaide again this year. Before we get started, really important to thank all the sponsors that without this, DDD just wouldn't happen every year. I'm super proud for CreatedAt, the company I work for, to be right there in the gold sponsors there. So thank you everyone on that list. So, the subtle art of intentional tech debt. Before we get started, hi, thank you for the intro, Andrew. I'm Ryan. I'm currently the CTO at CreatedAt. I've been at, most of my career, I've sort of floated around a bunch of different startups in Adelaide, as well as Accenture being the complete opposite of a startup, and ran my own consultancy for a number of years there as Blackstorm. I've done a lot of roles throughout my career, all the way from architecture, front-end senior engineer, back-end senior engineer, DevOps. So I've worn a lot of hats throughout my career. And tech debt is something that I've managed to deal with, and I'm sure everyone else does, at literally every single place I've ever worked. So, before we get started, we're going to talk about what actually is technical debt. Before that, I'm going to use a quote from one of my most favorite movies, Princess Bride. You keep using that word. I don't think it means what you think it means. Our definition of tech debt that we all use, I don't think is even really shared by us when we talk about it. So I think it's important that before we get into this, we do define what technical debt even is. So I had to go at first defining debt. I've defined debt as something borrowed from someone else with some arrangement of it being paid back, and there being some sort of consequence that if you just skip town. The debt that we mostly think about when we talk about debt is monetary debt. It's the standard one we think about loans and debts. It's all about money. We talk about money, there's a bunch of different types of monetary debt you can get into. There's loans for businesses, home loans, car loans, credit cards, things like Afterpay. These are all just different types of monetary debt, but they are different in their reasons, and some of these can be really wise financial choices and terrible financial choices, even if they're the same sort of loan. We think about the purpose for your loan. Maybe your business is booming and you're doing really great, and you're going to expand and open another shop and other stuff, great, and you want to borrow some money to do so, great. On the flip side, maybe it's a terrible business decision and you're borrowing money and it's just going to end absolutely terrible, but it's the same sort of loan. We think about terms being different. Some of these home loans, for example, have quite a long term, say 30 years. We talk about credit cards being a month. So they're quite different on just those different terms. We talk about the likelihood of payback. Home loans, they do all this effort into making sure that you're actually going to pay it back. They're all this credit checked and stuff. On the flip side, the credit card companies don't want you to pay it back because that's how they earn all their money, from charging you interest and all that sort of stuff. There are also changes in how they limit your agility. In the same loan for different people can mean completely different things. For example, if you have a massive home loan, and that's great, but you are the sort of person that likes to travel and work in different places around the world, having this massive home loan that's 30 years and a huge amount of money is actually limiting on agility if you do so. If on the flip side, you want to settle down and raise your family and all that, that limiting on agility doesn't really make it a bad choice or a good choice. I want to take a quote from my mate Steve, who says that on that list of ones, Afterpay is especially great if you like panic, regret, and poor life choices. So there are sort of loans that are very hard to actually get them in a good way, whereas other ones can definitely flip between. So I've decided to classify these monetary debts into two boxes. One is what I've deemed reckless monetary debt. Define that as an unintentional and or accidental arrangement where money is borrowed from another party with effects and repayment terms that are not adequately known, understood, or budgeted for. And this is typically due to negligence, error, incompetence, or ignorance. These are those loans that people go into without reading any actual details on the terms. They just, YOLO, cowboy, yeah, let's just do it and sign up to it. These are the Afterpay sort of style where you think, hey, I'd love a massive TV and I could totally afford $10 a month, can't I? And they just sign on the dotted line without really thinking about it. And in fact, a lot of this reckless monetary debt is actually exactly the sort of debt that some of these companies want everyone to have. The likes of Afterpay makes less money because of fees and late fees. That's how it makes its money. It makes very little on the initial bit. It's all on those late fees. On the flip side, we've got intentional monetary debt. Now, I've defined this as a conscious and strategic arrangement where money is borrowed from another party to achieve a desired outcome sooner. with agreed upon effects, repayment terms that are known, understood, and budgeted for. These are those business loans that you put all this due diligence into, ensuring that it is a good choice. You understand all the details, all the terms about the actual loan itself. So the main difference between these two types of monetary loans are whether it's intentional or reckless. That is that unintentional, accidental versus that conscious and strategic, making sure that it's the right choice to make and not just it sounds good at the time. We also have to remember that blind acceptance of not even bothering to read the terms of these loans is by definition reckless, because you can't understand or know any of these details unless you've actually intentionally and consciously gone into that and read all the terms. It's also different on the effects. So we talk about the effects of those two different loans. The effects could be on you as a person, but it also could be on your lifestyle. As I said, if you're the sort of person that travels a lot, some of these loans can be good or bad, but also having those, understanding the effects of these loans can differ, depending on things like that. The repayment terms is also how it differs. You note that I said that the repayment terms or effects have to be known, understood, and budgeted for it to be intentional. When we think about repayment terms for monetary debts, we think about things like interest rates. Do we actually know what the interest rate is? Is it fixed? Is it variable? How does that work? The time period. A home loan is a 30-year loan. Credit card's a 30-day loan. Very, very different understanding of those repayment terms of it. And the exit clauses. This is a big one where a lot of people don't go through the understanding that if things change in your life, whatever it is, and you need to get out of it, can you get out of it? And how does it actually work? Things like car loans a lot of times end up, if you exit early, you pay all of the interest you would have paid for the entire loan. Whereas home loans, you can get out early and pay some sort of fee, but it doesn't equate anywhere near to the amount of interest you would have paid if you stayed on the loan for the whole time. So, that's monetary debt. Well, how does that translate to technical debt? How does this work? Well, really, all we're doing is trading money for effort. And when we talk about another party, it actually is our future selves. And it's really important to think about it as it has to be us, or at least if it's not a future selves, ourselves, it's a future team. We have to make sure that we understand that we're probably going to be the one involved in it. We should assume that we are involved in it. John F. Woods has a really great quote that I normally use, which says, "Always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live." It's really important that we don't just code things without thinking that we're not going to be the ones there or the team there holding the bag once all is said and done. So if we go down that simple translation between monetary and technical debt, we can define reckless technical debt as an unintentional and or accidental arrangement where effort is borrowed from our future selves with effects and repayment terms that are not adequately known, understood, or budgeted for, again, typically due to negligence, error, incompetence, or ignorance. Now, interestingly, this is most of the time what we think about when we talk about tech debt. When we talk about it at work, when we talk about it amongst other co-workers and stuff, it's about this reckless one. This one where it makes you feel like everything, all the code we have at our company is terrible. Everything is just way harder than it should be, and everything just takes longer than it should be. It should take, you know how long this should take, but just because of the environment and the amount of this reckless technical debt in your system, it just takes longer. To the point where it starts hitting you to say, like, this is not as meaningful because I can't get the stuff done and I can't be proud of my work. And you start questioning why you're even maybe working in that company or a software engineer to start with. I talked last year about some strategies to work on these systems riddled with this reckless technical debt, i.e. dumpster fires, in an attempt to at least help people work through those obligations that have already been entered into by the time they get to it, whether it's them or other people. So on the flip side, and the important part of this talk today, is intentional tech debt. Again, we just changed the words. A conscious and strategic arrangement where effort is borrowed from our future selves to achieve the desired outcome sooner with agreed upon effects and repayment terms that are known, understood, and budgeted for. So when we compare this monetary versus technical debt, we think about these effects on you. Now, this isn't affecting on you financially. It's affecting on you maybe how you work, your morale, how much you get fulfillment out of the job you've got. Then we think about how it affects the team we're on. Well, monetary might affect your family. Technical debt affects how the team functions, the feature velocity, the morale of the team itself. But then also the company. Some of these technical debt arrangements that are entered into actually affect massively on the company you work for, and not just you, the code, the team you're working on. And it's not just engineering. On the side when we talk about repayment terms, well, interest rates are simply that cost, that effort cost you have and have to take on every time you do things. Technical debt becomes a burden of effort rather than a burden of money. Sometimes it's those things where you go to it, it just becomes every time you're like, oh, that's there, this is going to be so much harder every single time. And unfortunately, the worst sort actually end up getting worse and worse the longer in a system. At the start, it's just this small workaround, and then gradually you make all these different workarounds, and it becomes that pinnacle of your whole system is held on this technical debt decision that was made a long time ago. We talk about the time period. How long is this going to affect us for? How long have we signed up for this tech debt for? I really enjoyed the previous talk that I went to about launching into satellites, because I love the fact that you have a time period of this thing burns up after X years. It's an amazing way to just delete your code, because any features I develop will fundamentally be burned up in the atmosphere in a few years. So it's important to think about that time period of when is this technical debt going to go away? When are we going to repay it off? And then there's the exit clauses. This is an interesting one that a lot of people don't put all much thought into, because it's important to understand what's the cost to get rid of it. As I said, the satellite's pretty easy, it just burns up itself. But if you want to get rid of it, it's not just a case of just turning it off. You have to put this conscious effort into refactoring, re-architecting, whatever you need to do to actually get it out of the system. And does that exit clause get worse the longer time you go on? A car loan, the exit clause gets better and better because you paid off less. You paid off more of the interest, so you pay less at the end. Whereas a bank loan, sometimes the exit clause actually flips and it gets better, worse, the longer you go on, because of the bank's understanding of wanting to make as much money as they can from you. I wanted to start with a framework that I've been using. I want to make it obvious that when I say framework, this is not some crazily complex system that you need to learn. But it's the framework designed to help make sure that the debt we're entering into is of the intentional type, not the reckless. It's not about avoiding technical debt entirely, because I just don't fundamentally think that's the right thing to do. But it's about making sure it's of the right type. Now, it's a very simple framework. There's pretty much two things. There's the assessment, which is understanding those effects and repayment terms and making sure they're known, understood, and budgeted for. And then there's agreement. And that is ensuring that it's intentional and not reckless. We want to make sure that it's conscious, it's deliberate. On the assessment side, we think about the effects of things, and we have to think about how it affects specific technical tech decisions on maybe other projects we're working on. Does doing this stop us doing those other projects? Does it fundamentally slow down those other projects we're working on? How does it affect the team? Does adding this, am I going to make an enemy for my entire career here at this company because I did this thing and that I know Steve is going to have to deal with every single day? Or is it something that we can just spread around and everyone's sort of okay with? There's also the effects on the business. This is what I was saying before. Some technical debt decisions we enter into can fundamentally change how the company can move. If we enter into these technical debt that really limit what the company can do because it just holds the whole thing together, it is much wider than just engineering. When we think about this repayment plan or repayment terms on it, these exit clauses, again, understanding specifically about the technical debt decision we're making, how do we get out of it? How do we actually remove it from the code base? How do we architect it out? What does that cost? What is the interest rate? Actually deciding, is it going to cost Steve an hour? Well, if that's an hour every day, 5 days a week, 52 weeks a year. That's a lot of time. Whereas actually assessing it properly and going, this sounds really bad, but it's actually going to take me 15 seconds once a month. It changes how we assess that technical debt. And when you think about the time period, specifically, what is the time period of this technical debt? We can make different decisions on it based on whether we expect it to be around forever, we expect it to be around for a week. So going into the agreement side, this I think fundamentally is probably the harder part of intentional tech debt and making sure it is that. Because the parties that are involved in the agreement of this technical debt are engineering. That's pretty obvious. Most of us understand we're involved with it. But the agreement of this technical debt spans much wider than just engineering. There might be product owners that are understanding and inadvertently signing up for things they don't really understand. If you co-sign someone onto a loan without giving them any documentation whatsoever, they've suddenly been responsible for this loan that you've taken on and have no idea about any terms on it. But they're still there, partially responsible, 50% responsible for it. Sometimes it's all the way up to leadership. Actually explaining if we do this, it can fundamentally limit the agility of the company in a good way or a bad way. Now, small things, we can just take it as engineering. It can just be the cost of doing business, and that's fine. But other things where it spreads out become suddenly non-technical. And that becomes a lot harder for us engineers in the engineering department because we have to start understanding the motivations and what matters to these people. We know what matters to us, but what actually matters to them? What are they agreeing to? What are the effects they're agreeing to? And this becomes the case that it's not just about engineering. It is about the whole company. And where, even though engineering ends up being the ones footing the bill and we're the ones that have to fix it, actually the cost is borne by the whole company for a lot of these things. So we have to agree on both the effects, how it affects engineering, but the whole company, but we also have to agree on what their repayment plan is. If it's just us deciding that we need to fix it and they don't actually agree and understand what obligation the company is entering into or they are entering into on behalf of the team, it can change fundamentally how that works. Before we get into it, I thought I might go through some acronyms that might be a little bit helpful. Because I think sometimes when we have these little things to remember, it helps us when we're working through some things. So I'll just go through some basic ones first, just to make sure that we're all on the same page about what an acronym is. We've got KISS, which is good. That's Keep It Simple Stupid. It's a good one. Good one to use when we're working on things. We've got DRY. A lot of people know this one. Don't repeat yourself. Now, interestingly, that one had a bit of an issue because we found that everyone just focused on not repeating themselves and they made all these crazy abstractions just because they happened to copy 3 lines of code that was the same. So the geniuses, because I just love engineers that come up with the most, they come up with a new one called WET. Good. That stands for write everything twice. So this is good. So it's saying at least do it twice before you go into actually deciding there needs some abstraction there. Another one that's important, TLA, that stands for 3-letter acronyms. Good, we've got a few here. And FLA, which is a little bit confusing because it stands for both 4-letter and 5-letter acronyms. I'm not really sure how useful these are, but acronyms are how we function, so that's great. On the more technical debt side, we'll go through some acronyms that are a little bit more sort of relevant to what we're talking about. In the extreme programming world, there's an acronym which is, I don't even know how you're supposed to pronounce this, like DTSTTCPW, which stands for do the simplest thing that could possibly work. And it emphasizes on that sort of minimization of stuff and that really lean engineering. And out of that, a sort of a sub-acronym came out, YAGNI, which a few of you have probably heard. That stands for you ain't going to need it. Emphasizing that most of the time, if we plan for features that we think we might need and do all this crazy re-architecting and planning for the stuff, but the chances are we're probably actually not going to need it. However, I feel like sometimes that pushes a little bit harder on we just don't need anything. Like we shouldn't plan for anything. So they came with another one, which is YAGNI-Y, which stands for you ain't going to need it yet. So the extra yet sort of gives that little bit of, wait, hold on, maybe we should think about this. The C2 Wiki came up with one which wouldn't, which is a little bit sort of leaning on these both here. That stands for we don't need it yet. Now, I quite like this one as a little bit of a evolution because it emphasizes on the fact that it's we here. It's not that confrontational. It's not you, it's your fault. It's we as a company or we as a team that don't need it. But also pushes on that yet part of the previous one, emphasizing we don't really understand what we're going to need or not, and we should probably put some thinking into, well, do we need it? Maybe we should talk about it. I did attempt to come up with an acronym that would help sort of emphasize what I came up with here, but I realized that it's a bit hard sometimes to capture the nuances of some of these things. I came up with word, which stands for, we don't need it yet, but plan for what would be required if we did. Some of these acronyms aren't so useful for us to use always, but I think having these concepts and remembering when we're doing this and having that sort of simple framework can really assist with this stuff. I want to take a small tangent to talk about political capital because I think the agreement part of the technical debt part is a really hard thing to actually do. And it's hard because it's not about computers, it's not about software, it's about people. And we talk about political capital, for those who don't sort of know that term or understand what it means, it's about sort of brownie points. We talk about when we've done something good for someone, we might get brownie points. And when we've maybe done not so good, having those brownie points and be able to effectively spend them to deal with that time can help us work through that stuff. And it's important because really, relationships aren't binary. Relationships with management, relationship with your product owners, your other co-workers, they're not just good or bad. They're a roller coaster. They're sometimes really great because you're doing well, they're doing well. Other times they're doing badly, but not because necessarily you're doing it. Maybe they're going through a rough time. And understanding this political capital, understanding gaining these sort of brownie points and knowing when to spend them and how to spend them is a fundamental part of getting those agreements actually working. And it's important to understand that wording really matters, right? We are so thinking about our code length and our code formatting and all that, but when we talk to actual other people outside of engineering, we don't realize how important using the right words can make a big difference between them saying, yeah, let's do it, and you're crazy, there's no way we're even thinking about that. So for example, using us versus them versus we. It's not you saying to management, I think I'm going to do this and you're going to do this. It becomes we're agreeing to this, and we as a team, the whole team of the company, the whole team of the product owners, are actually embarking upon this agreement of this technical debt. As a good example, there's a difference between you promised to we agreed. I'm sure a few of us have been through the case where we've gone and they said, can you just do this? I know it's like a hack, but to put in, you're like, yes, we can. As long as you promise me, once we're done, we'll have time to fix it. Like, yeah, you have all the time in the world. It'll be fine. It'll be great, right? So inevitably, you work really hard. You know when you're going to fix it. It's great. You get it out. You're like, great, we're going to fix it now. And they're like, we've got those other projects and those customers that really want stuff. Like, do you have to fix it? And you sit there sort of begging them, saying, you promised me that I'd have the time to fix it. But if we flip it around to understanding that this technical debt was entered into as a shared arrangement, it suddenly becomes not you promised me. It becomes, no, we agreed that this was the path we were following. So you're not just letting me down, you're letting yourself down because you are also part of this arrangement that we went into. We're going to go a little bit into some stories from my career that might help understand how I've used this framework to ensure that we've made that intentional tech debt decisions rather than reckless. One of my favorite ones to talk about is CreatedAt. This is a thing that most people have dealt with when they're working on things where you just have this field that just tells you when this thing was created in your database. Whether it's a user or a house or anything you can think of, it has this CreatedAt field. And as engineers, we think, we probably should add it. But then we think, well, hold on. Yagni, right? We don't need it. I don't know. Do we need this CreatedAt column? We're good, diligent engineers. Let's go ask the product owner. Hey, I think we should add this thing. I'm not sure what to do with it. And they've gone, why? I don't care when a user was created. I'm like, yeah, but we could put it on the table. Like, we don't want it on the table. That's just confusing. So you're like, okay, well, I guess we won't do it. Is that the right option here? Well, so we started on the assessment side. Well, it's pretty easy. What's the effects? Well, we just don't do it. That's pretty easy. It doesn't affect us day to day. So it's pretty much nothing. On the repayment plan, what's the interest rate? Well, hold on. We're just not going to do it. I mean, if we add it later, it doesn't seem that hard. And then we think about, hold on, what is the repayment plan of adding it later? What is those exit clauses of getting ourselves out of this decision of not doing something? That's easy. We just add a field called CreatedAt. That's great. Well, what do you put in it? Well, people have been using this system for 4 years. They just put a value in. What value? Well, I guess we can make it nullable, so it's null sometimes, and then the front-end engineer is like, what are you guys doing? How come I don't know when this is created? The user interface looks terrible. So, all right, we'll put some date. 1st of epoch with 0. There you go, 1st of January 1970. And you get these bug reports from the users going, why does it say 1st of January 1970? That seems like an insane date that makes sense to engineers, but no sense to literally anyone else. So again, this constant realization that doing this effort of actually going into it makes us realize that that exit clause and that repayment plan was actually not what we thought it was. It was way, way harder because you can't make up data, especially user-entered data. And on the agreement side, we thought it was just engineering, right? Well, it wasn't until we realized this maybe we've just stopped us being able to put a bunch of features in because we don't have that field and we can't make it up and refill the data. We can't have this thing, hey, can you give us a graph that when a user were created? You're like, sure, it's like really high on the 1st of January 1970 and then there's nothing and then it moves. And then, yeah, I'm sure we've all had bug reports like that we all go, oh, that makes sense. And they're like, what do you mean it makes sense? That makes no sense whatsoever to anyone. So that agreement and assessment on that, just taking that conscious thought and taking 5 minutes to have a think about what actually is this? This seems like technical debt. Hold on, what is the assessment? And then getting people to agree on, if they're like, nah, you don't even have 5 minutes to add this. You're like, will you understand what we're agreeing to here? We can't make this data up later. I want to talk about another sort of technical debt-filled things. Proof of concepts. I'm sure everyone here has had this amazing one where the business people come to have got this bright idea, right? They're like the almighty pivot. They've gone, hey, you know how we make pizzas, right? You're like, yeah. Could we make wrenches? And you've just gone, I guess. I mean, we have machines that could maybe change it. And they've said, okay. And it's the pretty much throwing shit at the wall and hoping to see what sticks. That's pretty much what they're saying. But suddenly it's like, no, we need it yesterday. I'm telling you, this is the thing that the company needs. In fact, we've got customers waiting. As soon as we have this, $10 billion valuation, right? Sure, a few of us have heard this before. But POC is not the same as a production grade level of feature. This is very different, and pushing this understanding up, like a lot of the company think of it, aren't you guys just coding? It's just code. How is there any difference between that hacky one and the other one? Well, really, it's an entire spectrum. We go from the hack on this side all the way to production grade here, and then sort of this middle blob is like that, yeah, it's okay. If someone's like, hey, is this good? It's not terrible. It's definitely not here, though. We don't have a bunch of stuff we need. So if we think about using that fragment on those three levels, we think about on the hack side. So on the hack side, we think about something that's definitely the quickest. However, it is most definitely the dirtiest. And we think about the effects on the team and everyone else and think, well, short term, it's actually a bit of a morale boost because the company's really happy with it. Oh, you guys made that thing. We're on track to 10 billion valuation. I mean, nobody's bought it yet, but I'm telling you, it's going to happen. So it's really great. But long term, all these little ones, they add up. And it actually can be a drain entirely on the team when we have these. The repayment plan, well, the exit clause is we just need to delete it. That's it. This is like the hackiest thing we can think of. It just needs to be gone. The interest rate is really high. And in fact, sometimes becomes compounding. This little hack we've added, they're like, it's fine. It just gets worse and worse as everything changes. It should be very, very short term, that time period. That's what this hack should be. So that's sort of that side of it. Well, what's the agreement side? How do we actually get them to understand what they're agreeing to? Well, we have to all agree this is literally duct tape on spaghetti on Band-Aids. This is not a thing that we actually wanted to do, but you asked us and we're being nice engineers and all that. We have to make sure they realize it's got a fixed, short time span. And if we want anything, this needs to be rewritten, right? We just tell them that. Like, no, it's not, I'm not kidding, though. It actually needs to be. Like, this is not a, yeah, this actually needs to be rewritten. And actually having them to agree to that. And also it can't scale. This is a hack. This definitely can't scale. However, this actually is a great example of the right choice when you have low confidence. If you are throwing shit at the wall, this is actually the right thing to do. As an example, one of the companies I worked at, we did power monitoring. And the CEO came through one day and said, guys, so we're going to do carbon credits. And we've said, carbon, what? What are we doing? So I've told the stock market, that's what we're doing. And we've gone, this is insane. We don't even know what this stuff is. How does it work? So we came up with the almighty plan to say, all right. We're going to put a link on the page that says, we're doing carbon credits now. If you're really interested, click here. And we made the hackiest Google form you can think of that let them just re-enter their details. They didn't copy anything, just re-entered in, right? Amazingly, nobody clicked it. Just no one. No one whatsoever clicked this button. And so we got to do my favorite thing ever and just delete it. We just deleted all of it and we all just merrily pretended it never happened. On the flip side, when we're using a hack and we don't have someone's agreement stuff, we might end up spending an entire week working insanely hard. Everyone's working long hours because we've got some crazy customer that I'm telling you is going to sign up. They're worth all this money. We just need to get it done. And we're like, this is the craziest hack. We haven't planned it, nothing. We put it in and it's great. And then months later, the customer's gone. And guess what? That technical debt that's in there is in there for literal years. People are finding it years later and going, what even is this? Oh, let me tell you a story. Well, we had this customer and it's still there, right? So it can be the complete wrong thing to do. Because there is a really good quote that I like from Carl Simpson that says, there is nothing more permanent than a temporary hack. So with the middle one on this sort of okay side of things, we talk about what the assessment is on an okay level, somewhere in that middle. So it's not going to be the quickest, definitely not going to be the quickest, but it's definitely not going to be the dirtiest. We put some thought into it. This is not, we haven't spent all this time planning, but we've sat down and had a few meetings and said, how are we actually going to do this, right? And we think about the effects. Well, it's not our best work, so we sort of know that. We're like, yeah, it's okay, and it could slow us down, but it's not terrible. It's not the hack level. We still feel somewhat good about it. What's the repayment plan? Well, the exit clause are we need some work. This needs to have work on it. This needs to have some refactoring, re-architecture happening on it before. It's sort of medium interest rate, sits right in the middle. hopefully it's fixed. It costs us a bit, but we know what it costs, and we've sort of analysed it and understand that, and we're sort of okay with it. And it's on that medium term, sort of maybe months. Hopefully not years, but months, right? So on the agreement side, we have to all agree, everyone has to agree, this refactoring is going to be required. We can't just launch this and just leave it and hope everything's fine on it. We might even need to switch frameworks. We just chose one because it seemed great at the time. We hadn't really put much thought into it. The feature velocity is going to be lumpy, and by that I mean it's going to be up and down. When we first released, we needed to do a lot of cleanup, so we're going to spend some time doing that. We can't make features. Then we're going to open us up to some more features. Then we're going to hit the next bump. Like, oh no, all right, we're going to do that. We've got to refactor that bit now. So it becomes that lot of lumpy understanding of feature velocity, which everyone has to agree with and understand that it's not going to be hockey stick style, right? But it will scale to a point, and we have to agree on what level it's going to scale to. And we need some planning to be done before work actually commences. We can't just go into it and rip out our laptops and start writing code. We need to talk about it first. This is a really good choice if we have some sort of confidence. The business is like, yeah, maybe it's a thing we want to do. I don't really know. So as an example, at CreatedAt, we build a system for manufacturing roller blinds and curtains and such like. And we need to track when they're making it, what state it's up to, whether it's in progress, whether the thing is being done, so we can track it. So we made the decision to say, well, actually, if we're going to track that, we probably should track the transitions between them, because that's really what seemingly is important. But then at the same time, we really only need to know what status is. And now nobody wants to know all that history right now. And we're going to add it, and it's going to be understood that it's going to make things harder. Every time we add a new feature before people want that, we're going to have to say, oh, there's this weird state machine we have to deal with, and there's history table. We have to make sure there's no overlaps, because everything's terrible, all that sort of stuff. However, when we want any feature with it, we have all history to the beginning of time. There's no making up of stuff. There's no null dates. It's all there. So it can make a really, really good choice sometimes when we actually assess and get agreement of what this actually means. So production grade. This is the other end. This is very, very much not the quickest, but this is like chef's kiss quality. This is like, we love this. This is like so good. We've spent like 2 years developing this. Everyone's happy. So the effects are like, yeah, we're all like pumped up, high quality, super proud of our work. That's great. What's the repayment plan? Well, the exit clauses are huge because we spent 2 years. This is like, we're going to throw away 2 years of effort. This is just hugely high exit clauses. The interest rate is probably low. I mean, we're going to pretend there's no tech debt, but let's be honest, there's going to be some tech debt. But it should be minimal, right? That's the whole point. We've put effort in, right? The time period, short of this, should be sort of the payment of that tech debt is low because we can get rid of it quickly, or the one that's there doesn't really matter too much. So we understand what that interest rate is. So on the agreement side, this is when we talk about, we tell them, this is going to take time, like a lot of time. This is fundamentally the opposite end of the hack. And we cannot start coding until there's a plan. Like, what even is this thing we're talking about? And I'm talking about an actual plan. Like, we have the future features. We know what we're doing. There's a backlog. There's like sprints. There's all this stuff that's actually planned, and we understand what this whole thing is going to look like. But it does result in great feature velocity. We're out of the gate. We already know what we're making, so we're pretty much on that feature velocity straight out of the gate once we launch. And this is actually a really good choice if we have a really high confidence, the business does, we do, that it's the right thing to do. As an example, at CreatedAt, we had a retail system to help people sell these roller blinds and things, and we decided that we wanted to get into manufacturing. That's a huge thing. That's completely different from selling roller blinds. However, it was the decision of the company saying, no, this is the future of the company. This is not just a little thing. This is the future. And so we said, well, if that's the case, we can't hack it. This needs to be production grade, out of the gate. So we did spend literal years building this, but it had full automated tests, full security checks, all this sort of stuff is in there that you'd expect, and it scales to, I don't even know how far, because we understood that from the get-go. And so it can be the right choice. The other thing is when safety or stuff comes into the fact, that can also make a difference here. So the middle one, a little bit of a deeper example into it, that middle OK section. I'm going to talk about one of my previous workplaces. I was overseeing the launch of this new software. Now, I'd worked mainly in architecture and back-end, and I was handed this React code base. Now, I was been told it's been developed for 6 months. There was one external contractor, and they were really, really good. I think all of us know where this is going. I was super naive at this point. I'm like, yeah, okay, yeah, I can do this. So they said, just get into production, just launch it. And I'm like, well, okay, hold on. If I'm responsible, I need to actually check this. So I started assessing it. But I understood that I needed to assess it on what mattered to the team, to me, and to the business. And I realized that it wasn't about quality. It was about, can we add features to this thing? And actually, more importantly, can we add the features, and my other team members add the features efficiently that we want to add in the order of priority we want them? So I went and tested it. I tried a few. And I found, very quickly, the entire thing was reckless tech debt. The entire code base. So I did what I tell everyone they should never do, and I suggested we burn the entire thing to the ground and start again. So this is where the political capital came in. I talked to head of engineering, and I'm like, this is terrible. We need to start again. He's like, are you sure? Like, this is serious. Spend 6 months. This is crazy. I'm like, look, I really think we need to do this. And in fact, what we're going to do is I'm going to invest political capital, and you need to trust me in this. However, we're going to agree that give me a month. Give me a month and one contractor that's actually good, and we're going to see how we go. We're going to build something. Now, we had a month. I knew I had a month, so I had to work out how I was going to do this in a month. What does that mean? So I'll go through a little bit more of a technical example of the sort of decisions we made, technically speaking. So this is a React Wrangler function. Sorry for all the front engineers, because I'm going to take some liberty with syntax and other things. But we've got this thing at the top that renders a component that says, hello, Fred, and we call it using this thing at the bottom. We pass the name in. That's great. Now, maybe what we end up doing, we'll give it some types, because I like types, so it's got a name. We do some crazy intense calculation before we show them a name. Now, React's got an amazing thing where it can be very smart on optimization and realize, well, if the name doesn't change, I don't need to rerun this component again. I know what it looks like. So those intense calculations, they don't have to happen over and over and over again. Maybe we add a company name to it now. And what's cool is now it actually only re-renders when either of them change. So even that intense calculation still happens very often, not very often. Maybe we go all the way to the other end, and we've got this sort of user ID here, and we've got this fancy user service and a company service, and we look it up. And now we're going to say that we know that the company name and user name doesn't change unless the user or company actually changes. So with that, in fact, and understand the optimization, doing this, what we did, which is literally put every object we can think of into every single component that we had in the whole thing, is terrible. It is the wrong thing to do, technically speaking. It's just horrendous. It slowed everything down. The optimization, it was just terrible. However, we knew how to get from here to here. We just removed the stuff we didn't want. So we knew it was going to cost time. We knew that we had to analyze and do it all, but we knew what it was. We actually understood that cost that we're talking about of ripping it out. This is just one of the decisions we made. We made a buttload of them, so many corners cut. But these are corners cut that we understood and we agreed, and we understood what would happen if this went to live, and we're hoping it did. So the good news is, it was successful. However, we spent an entire month after we were done cleaning it up. So this wasn't 1 month, this was 2 months. But we agreed to that before we started. We then took another 6 months to actually clean it up. So this thing that we made that only took 6 months actually took 8 months to effectively get to the same spot we were to start with. And the feature velocity was, it was okay. We knew what it was at launch. But then once we got to that cleanup, 6 months, it was great. We knew exactly what we were going to do. We understood where all the skeletons were, and we knew how to get rid of them. And it actually earned me a bucket of political capital there, because they're like, oh, well, maybe he does know what he's talking about. Maybe sometimes we do need to assess these things. It could have failed. It could have failed spectacularly. It could have totally failed. I could have just come back, tail between my legs, going, yeah, I can't do this. The other one was actually better. But the thing was, even if it had failed, I had a month. And I had a month that if it did fail, no one's going to go, Ryan, you wasted a month doing that. We're like, no, we all agreed I was going to spend a month as other contractor, and if at the end it was terrible, we'd all just go back to where we were and never talk about it again. Mostly. So when we talk about technical debt, I want to make sure that we realize technical debt isn't just a bad thing. It's also a superpower when used correctly. And I like Spider-Man. It's got a really good quote here just to say, remember, great power comes great responsibility. We can do amazing things when we do things correctly. When we don't, however, it can be terrible. So the takeaways from today I just want to go through is the fact that technical debt isn't bad. That doesn't mean bad. It's the difference between that reckless and intentional that actually makes the difference. And the framework that I went through, it's just a very simple one. We just need to stop, think about, and assess what this technical debt decision we're entering into means for the company and for us and what that repayment plan is. And then, probably more importantly, people have to agree to this thing. If people don't agree, we can do all the assessment we want, but we're still the ones holding the bag at the bottom. And this agreement is probably the harder part of the whole situation here. And understanding that it's all about framing that assessment and trying to make sure what matters to people is what actually can get us through to getting that agreement and being successful. I want to leave you with a quote from myself that I find sometimes helps remind me what we're talking about here. It starts with this: clarity beats perfection. When everyone understands and agrees to the trade-offs, even the wrong choices can be the right move. Well, thanks everyone for listening to my talk.